Hello everyone, I hope you are doing well. So in this video, we are going to discuss Leetcode problem of the day, and today's problem is number of submatrices that sum to target, and it is a hard level problem. So this problem is not necessarily very hard, it's just one concept that if you have not studied, you might find this problem difficult, right? So let me just tell you what the problem says. It says that we have been given a matrix and a target. We have to find the number of submatrices such that the sum in that particular submatrix is equals to k. So what is a submatrix? Let me just take this particular image. So if I can just right, so we have this particular matrix that has been given to us. Now what we basically have to do is we have to consider any submatrix. So this is a submatrix, this is a submatrix, and this whole is a submatrix, and this is a submatrix. Basically any rectangle that you can figure out in this particular matrix, right? So you have to figure out any rectangle and find the sum of that particular rectangle, and then figure out whether the sum is equals to target. So we have to find all the number of such rectangles such that their sum is equal to the target. This is our whole question. Now if I look at the constraints are up to 100 only for both n and m, right? So to form a rectangle, my first idea is finding out two endpoints, right? So whenever I have two endpoints, can I form a rectangle out of it? Yes, definitely. The rectangle will look something like this. So that basically means to construct a rectangle, I need 2 points, right? So how many number of points are there in this particular matrix? The total number of points is n cross m, right? So the value of n and m is up to 100. So this will be the number of points. That means 10 raised to power 4. Now if I have to find two such points, I can go through all the configurations. That will be this particular thing square. So that is 10 raised to power 8, right? Now my complexity has already reached 10 raised to power 8, but I have been able to figure out all the rectangles that are present in this particular matrix. Now if somehow I am able to figure out the sum inside of the values of that are inside this particular rectangle in O of 1, that means I will be able to solve my problem. So let me just reiterate what I just said. The first idea that I communicated was that to form a rectangle I need only 2 points, right? Then I discussed the complexity of finding 2 points in this particular matrix, that is 10 raised to power 8 operations in worst case. That is within our time limit. Now then I said, if we are able to figure out what are the sum of these values inside any rectangle in constant time, then we will be able to solve our answer, right? So this is our only task, to find the sum of all the values inside each of these rectangles in constant time. So there is a one very popular technique that you might have not heard if you have not solved this problem yet. So what we generally do in a one-dimensional array to find out the sum of values in any particular range, we use prefix sums, right? So how do we use prefix sums? This is a, then this is a plus b, then this is a plus b plus c, and then this is a plus b plus c plus d. Assuming the initial values were a, b, c and d like this, then this will be the prefix sums. If I want to figure out the sum of values in these two cells, then what I will do, I will take the last value a plus b plus c and I will subtract this particular value minus a. This is b plus c. This is how I find prefix sums in a single dimensional array. Now I want to extend the same approach in multi-dimensions array, right? So let me just create rectangle. So it did not get created. Let's say we have a rectangle like this, then we will have these lines. So now you see I have a matrix. So in this particular case, when we had only a single dimension matrix, each value or each cell I was storing the sum of values from 0 to I. In this particular case, I want my each cell I comma j, because this is a double dimensional matrix, each cell is going to be represented by I comma j. Now each cell I comma j is going to store the sum of values from 0 comma 0 up to I comma j, right. So basically if I comma j is this one, I am going to store the sum of all the values in this particular range, in this particular cell. Now the very first question is, how do we actually do this, right, because this is not as simple as it might look. So first of all, my dp of ij is going to be matrix of ij, because first of all we are going to take the value that is present in the current cell in the original matrix. Now if I is greater than -1, I am going to add dp of ij plus is equals to dp of I minus 1j, and if j is greater than -1, j is greater than 0 actually here as well, I am going to add dp of ij plus is equals to dp of I j minus 1. So till now what we have done is, first of all I know that I am at this particular position ij, this one. Now in the original matrix, from the original matrix I have taken the value and stored it here. Now I have to take the previous values as well. So one value will come here and one value will come from here. So this is represented, this point is represented by I minus 1, that is what I have taken here, and this particular point is represented by j minus 1, and that is what I have taken here. So basically the previous values are considered. Now there will be one slight issue with this particular approach for till now, and that is, let's say this particular cell contributed to this value and this particular cell also contributed to this particular cell. Now these two cells have individually contributed to this particular cell. So basically if I had a value a here, this value would have propagated to this particular cell, right. Whenever it was traversing, whenever it was in this particular cell, I would have added j minus 1 from this particular position. Similarly this particular a would have also traversed to this particular cell. Basically when I was at this particular cell, I would have added this value by I minus 1, right. Now this a is now communicated here and here as well. So instead of a being present only one time, I actually have 2a now, right. So to erase one of these effects, what I am going to basically do is, I am going to add one more thing, that if I is greater than -1, I is greater than 0 and j is greater than 0, that means both of them are greater than 0, I am going to set dp of ij as minus is equals to dp of I minus 1 j minus 1. So I just mistyped it up here, I am going to do plus is equals to. So basically what happened now, I knew that somehow I am getting two contributions from the same cell. From this particular cell, one A is traveling here and then here, and the other one is traveling from here and then here. So in this particular cell I have two contributions. To negate one of those, I am just directly going to subtract dp of ij minus is equals to dp of I minus 1 j minus 1, and that can only happen if both I and j are greater than 0, right. So if you do this for all the cells, now each of your cells will have the values or the summation of values from 0 0 till cell I comma j, right. Now the question is, how do we compute if we have two points, the starting point sx comma sy and the ending point ndx comma ndy, then how do we compute the sum of values in this particular rectangle, right. This is our next question. So let us discuss the second part as well now. So what we generally do is, let's say I am going to write my I comma sx, let's say, and sy. So I am writing, let me just give you the convention which I am using. Yes, so this is x increasing down here and y increasing here, right. This is the convention that I will be using. So let's say sx is here and this is ndx actually. So let me just quickly change this. So this is ndx and ny, and this is xx and sy. So this is denoting the starting point and this is denoting the ending point. Now I want to figure out what is the sum of this particular rectangle, right. Now if I take the value at prefix of ndx and ny, it is actually going to give me this particular part, right. Now this particular value is extra here, right. So how do I remove it? Let me shade the extra value. So this is the extra value that I have, and this is the extra value again that I have, right. So what I am saying is, if I use the prefix of or dp of ndx ny, I'm going to get the sum, but I'm going to get this particular value extra as well. So how do I remove it? I will take two things. The first thing is dp of, let me just write it only. So I'm just going to write it properly. So I have taken current answer as dp of end x and end y. Now I'm going to take two things. If start x is greater than 0, that means what I can do is current minus is equals to dp of sx minus 1 and end y. If my end y or start y is greater than 0, I am going to do current minus is equals to dp of end x sy minus 1, right. So basically let us just study what we have just done. So if sx is greater than 0, sx is basically this particular row. If it is greater than 0, I am going to subtract sx minus 1 and ny. So ny is this particular part, this particular column, and sx will now become this one, sx minus 1. So I am going to subtract this whole part, the upper part, right. Similarly, if sy is greater than 0, that means this particular column is greater than 0, then I am going to subtract end x minus sy minus 1. So sy minus 1 is this one now, and end x is this one. So now I am going to subtract this part, right. But similar to what happened earlier I added this particular part twice. Now you can clearly see that this particular part has been subtracted twice, right. So you can see this particular part is shaded by red also, and this is shaded by green also. That means this part was removed twice, and that is not certainly what I want. So what I'll do, I'll add back the remaining part. So if sx is greater than 0 and sy is greater than 0, I am going to do current plus is equals to dp of sx minus 1 and sy minus 1, right. So this is only to add back the remaining part which was removed twice, this part right here, right. So this is for calculating the prefix sums, and this is for calculating the final rectangle values, right. These are the only two things that you need to do. This is not very difficult, as I said. This is just an observation which you might not have earlier if you don't know how to solve this kind of problems, right. So this was all about this particular video. Let me show you the final code. So the code is very simple. It's exactly what I've just written till now. So I've initialized the dimensions of the matrix, and I've initialized my prefix vector with n cross m, right. Now what I've done is I've created a for loop n cross m, and prefix of ij is equals to matrix of ij. If I is greater than 0, I'm just going to add prefix of I minus 1j. If j is greater than 0, I'm going to add prefix of ij minus 1. If both of them are greater than 0, then I'm going to subtract prefix of I minus 1 and j minus 1. This is only because I must have added this particular position twice, so I have to remove it one time. Now I initialize my answer with 0. I have 4 for loops. First one is sx, then it is end x, sy, and then end y. Now you can clearly see that end x is always starting from sx, so that it is greater than or equals to x. Similarly, my end y is starting from sy, so that it is greater than or equals to sy. Now we initialize my current with prefix of ex ey. Now if I say sy is greater than 0, I am going to subtract prefix of ex sy minus 1. If sx is greater than 0, I am going to subtract prefix of sx minus 1 ey. And if both of them are greater than 0, then I am going to add that particular part which was removed twice. Now if current is equals to target, this boolean expression is going to return 1, and that is getting added to my answer, and at the end I will just return my answer value, and this would be the final solution. So let me just quickly submit this and show you that this particular code works and this solution is absolutely correct. So you see, this passes all the test cases and this solution is correct. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video, and don't forget to share thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.